All right, we're going to take a look at another practice problem where we're going to have a set of equations that you see here, and I'm going to show you a graph. I'll show you in just a second. I want you to look at these equations and see if you can visualize what the graphs might look like. Okay, I purposefully grouped them. The first three, you see that the slope m is a positive 1, and then these last three are uh, have a slope of -1, right? So the m value is the slope. And the variation in each of these sets is the b, the y-intercept. See if you can visualize what you expect these these graphs to look like. So hopefully you visualize something like this, where you remember that if you have the same slope, m, right, 1, 2, and 3 have the same slope, you can expect that these lines will be parallel. And they're parallel, meaning they're never going to intersect. And then same thing for lines 4, 5, and 6. They're going to be parallel to each other. So we can quickly identify which lines match. If you want to try it for yourself, pause the video and see if you can match them. All right, hopefully you had a chance to match the lines with the equations. So the positive slopes, right, positive 1 slopes for 1, 2, and 3 are represented by B, F, and D. Now we figure out which one it is. Now how do I know that those are the positive slopes? Well, positive slope means rise over run is positive. So as x increases, y also increases. So x increases means you move to the right, y increases means you move up. And so you can see that is true for this line B, F, and D. And then the reverse is true for lines A, C, and E. As you move to the right, so y drops. So x increases, y decreases. And so now all we need to check is the y-intercept. So if we first look at the positive slopes, 1, 2, and 3, which are associated with B, F, and D, we can look at the y-intercepts. So line B, we can see that intersects the y-axis, right, this vertical line axis here, at 0.5. So line 3 is B. And then F intersects the y-axis at 0.3. So positive 3. So line 1 is F. And then D intersects at -4. So line 2, equation 2, is D, right? So now we can look at lines A, C, and E, which have negative slopes, and associate them with the corresponding 4, 5, and 6 equations. So equation 4, we see the y-intercept is 0. So we will look for the line that intersects at the origin, which is line C. So 4 is C. And then we can look at any of these. Let's look at line A that intersects the y-axis at -6. So that's equation 6. And then line E intersects at +2. So that's equation 5. And we can also check to make sure that the magnitude, right, or the numeric value, we know that the positive or negative sign of the slope is correct, but we can also double check that the size of the slope is correct. These grids are built so that they're a unit grid, right? So each dash mark represents one in the x or one in the y direction. And you can see these lines intersect at the corners, which means you move to the right one, looking at line C, and then you move down one. So that's -1 slope as you move across. And then let's look at line F. As you move 1 to the right, you move 1 up. So these are accurate. They are parallel. They are represented as either positive or -1 slopes of M. So hopefully that made sense. We could do a couple more practice problems like this and look at the effects of different changes in M and B. The more you practice these, the better you'll be able to look at a variety of forms of these equations and visualize how they will look. We'll do some more practice problems on intersects. We'll also look at practice problems on comparing different line equations and lines.